Hello everyone, I'm Stephen. Because each author of this study is responsible for the corresponding part, not all authors understand each other's contents. So we plan to hold an internal briefing on the study. Today, I would like to talk about a study I almost redesigned and finished during the inner rebuttal period. And the topic is estimating divergent carbon stocks and sinks knife set approach. Before start the presentation, I needed to make a confession at that outset here. A little over 10 years ago, I did something that I regret, something that I'm not particularly proud of, but here I feel a kind of obliged to reveal. In the late 2010s, in the moment of young indiscretion, I went to an university. At that moment, I did not do very well in English exams and was still like a naive idiot. I even thought, ignorant, that machine learning should be a cool science fiction technology, something like that. But today, against my better judgment, I want to try to dust off some of those machine learning skills. What's left of those machine learning skills. And I don't want to tell you complicated technical details. I want to make a case. I want to make the hard-headed, evidence-based for rethinking how we conceptualize the knife set approach and how we estimate the carbon sink and stocks. And here is my outline. I will reveal the purpose in introduction and describe the knife set approach in materials and methods, and then discuss about some new findings and compare our methods with IPCC's methods benchmark and make a conclusion. Around 2 years ago, Kobayashi Sensei and I shared published research articles with each other, and then we found one paper mentioned that when the annual mean temperature was increased and the above ground biomass of moso bamboo was increased in Taiwan as well. However, it's totally different in Japan, he said. Hence, a question is formed. Is the phenomenon possibly like a carrying capacities index such as forest above ground biomass? And we made an assumption as the figures, and there is a temperature period is suited for moso bamboos growing like this figure. Too hot or too cold will cause the above ground biomass of the moso bamboo decrease. And after that, we collect moso bamboo's forest data from Japan and Taiwan. And the distribution of the biomass and the annual mean temperature shows like the figures. And we found that even though the assumption is partially correct, it may have some hidden variables existing behind the phenomenon, because we also found a lot of observations seems divergent, and if I added data from China and Korea, our assumption above is not easy to prove, so we stuck on the assumption here. On the other hand, the above assumption reminded me that Dr. Chen Caihui and I was trying to use regression model to predict the moso bamboo biomass and the carbon stocks about 7 years ago. And this kind of model has a good ability to evaluate the above ground biomass, but very awful in below ground part. And we cannot solve the problem if the independent variables and the dependent variables divergent on the distribution at the moment. Perhaps it's necessary to find a method for below ground carbon sink and stocks. And we want to build a model which can be used to predict the dependent variables when the independent variables are divergent and chaotic on the distribution in ecological systems. So, previously, we was used the mice method, which is Gibbs sampling type Monte Carlo plus linear regression and the random forest methods to imputate the raw dataset. then use the bidirectional stepwise regression methods to build a series of linear regression models and output the prediction. However, the method contained some part of pseudo data, which means if some factors are not so have a higher explanation power, it perhaps will cause the overfitting in the output. And furthermore, after that, Richard and Simon and I built a hybrid method which combined the time series ARIMA and gave sampling with random forest to estimate the stock price, and it seems workable for estimating divergent target variables in chaotic systems. That experience led me reconsidered how about to use the similar structure to estimate the chaotic or divergent variables. Okay, so let's start today's internal briefing. And for the first part, what is necessary to investigate the biomass and make carbon storage models in bamboo forest? And I think because of land use changed, especially in deforestation and agricultural activities, increased energy consumption and burning fossil fuels, which comes from the below ground, the greenhouse gas emissions have skyrocketed after the Industrial Revolution, and the greenhouse effect has intensified recently. And all above reasons are very likely causing global warming, which is also inducing extreme weather and climate change. And the carbon stocks in vegetation is an important role in carbon cycle, which affects carbon dioxide emit in the air on Earth. And for combating the hard-core problem, the United Nations Framework Convention on Climate Change is adopted on the 9th of May in 1992. And in the UNFCCC, a lot of countries will arrange some policymakers to attend their conference. Intergovernmental Panel on Climate Change will provide scientific reports and studies to the UNFCCC and help policymakers to assess climate policy. So, forest carbon sink and stocks are also important for policymakers to assess policies of mitigation. However, a allometric model of carbon stock and sinks of below ground in bamboo forest looks always low accuracy. Why? Before answering, we need to talk about the spatial characteristics of bamboo. Here we provide a case of Philostachys edulis, and bamboo forests are widely distributed in the world. For instance, you will find them in Asia, America, and Africa. But somehow, 2 years ago I saw some planted bamboos in France as well. Anyway, most bamboo is a kind of temperate wood bamboo and widely distributed in Eastern Asia. And because of bamboo have no cambium, they will accumulate dry matter in the secondary wall year by year, and after finish their growth at the age 1, they do not consume quite a lot of carbohydrate anymore. And due to mature bamboos do not consume too much carbohydrate may transport to other bamboos or shot. And so far, some study revealed that most bamboos have a rhizome system and they can transport carbohydrate and the nutrient to somewhere. This may be one of the main reasons that below ground biomass AMPP and BMPP are divergent in bamboo forest. Okay, now we get back to the problem nowadays of the climate change. And even though carbon storage in vegetation is an important factor in carbon cycle, the method provided by IPCC's guideline is a little bit rough, especially on estimated bamboo carbon stocks and the sequestration. So let's just rely on one study from Africa, and its parties of UNFCCC may use bodily forest data to calculate the carbon stock and the sinks in bamboo forest. Hence, the purpose of this study is to investigate biomass, carbon storage, and nutrient contents in soil of moso bamboo forest, and to collect previous published journal articles data, and to design a method combined linear regression and the random forest with skip sampling approach for estimating carbon stocks and sinks in forest. And our study site is in FFPRI Kansai Research Center in Japan, and the annual temperature is around 16.4 Celsius degree, and the annual mean precipitation is 1,705 millimeter per year, and DBH is around 9.7 centimeters, and the height is nearly 15 meters. The calm density is around 9,000 per hectare. Furthermore, the total biomass is 186 megagram per hectare. All of them are larger than the average size in China, Korea, and Taiwan. At the beginning of the series studies, we set study site and the sample plot in investigation biomass, especially in above ground biomass and below ground biomass, and then dried the samples and run elemental analyzer to know the carbon ratio in biomass to estimate the carbon stock and the sinks. After we obtained the data for carbon stock and the sequestration of moso bamboo forest in Japan and Taiwan, we also collect other reliable peer-reviewed articles on Google Scholar and read them carefully and record their details. And after we collected data, we start to wash and certificate data, and this step took one of my summer vacations last year. I totally hate this step very much, but it's quite important for the further analyzing. And after washing data, we got a raw dataset and started to use our software to check all relationship between the variables and build linear regression models for estimating regular target variables as output of the first layer. And following this, we estimate divergent variables via random forest with escape sampling assembled algorithms. And because it's like a random forest wandering in the highly dimensional space, so we named it Wandering Through the Random Forest Algorithms. And the random forest is a kind of assembled machine learning method, and because our data is tiny and have a lot of missing values, it has a good ability to remove the linearity and prevent the result become overfitting. At the beginning we wrote the draft, I used the term in simple hybrid approach, but Kobayashi-sensei and Morikuchi-sensei don't think it is simple enough, so I used the concept that Mokuto-sensei provided in a seminar. And we emphasize that if independent variables and the target variables have a good relationship with each other, then we use linear regression model as an output. And if the linear regression models can't estimate them, it will let wandering through the random forest to give an output. And if above methods still can't provide the values of estimation, it will use the climate classification tables to give an output. It can at least ensure that the accuracy of the output result is high. Also, the precision sometimes might be relevantly low. And now we talk about the detail of linear regression models. We operate Pearson correlations testing between all variables in raw dataset, and if p-value is below 0.01 between two variables, then make simple linear regression models. And after we explain the linear regression, the output will go into the second layer. And the second layer, the random forest and the gap sampling will treat them. And let me explain what is random forest. Random forest is an assembled method of many classification and regression trees based on randomly backing and form the new vectors randomly. And the raw data will be divided into train set at 63.25% and the test set at 36.75% for out-of-bag test. And if the error rate over 50%, random forest will not output values. And this method is brilliant to solve the collinearity. And I think you may have a question now, what is CAR-tree? CAR-tree is an abbreviation of the classification and the regression tree models. If we want to make CAR-tree models, we need to select the optimal segmentation variables J and the segmentation point S, and formula things like reader unfriendly. Let me describe that more below. I want to make a simple case. I assumed the data sheet like this. The simple data recorded 3 study sites in Japan and 2 in Korea, 2 in Taiwan. If we choose J as a country, there will be 3 different divided types. The types 1 is R1 as in Korea and R2 as in Japan and Taiwan. And the type 2 is R1 as in Japan and R2 as in Korea and in Taiwan. And type 3 is R1 as in Taiwan and R2 as in Japan or in Korea. And if we use the mean annual temperature to choose the best divided type, then we get to calculate each group's mean square errors and then find the minimized mean square errors combination. And the type 1 mean square error is 59, and the same as above. The type 2's mean square error will be 97, and the type 3's mean square error is around 18. So after that, we found the type 3 is the minimum MSE, and it is the best divided structure, and repeat the procedure until all variables have been classified. And then we made the CAR-tree models. And if we assemble replicated result together, it will call random forest. So following this, I would like to talk about what is Gibbs sampling. It is a Markov chain Monte Carlo algorithms for obtained a sequence of observations which are approximately from a specified multivariate probability distribution when direct sampling is quite difficult. And I still do not know what that was, and I read a lot of papers and conclude that in a simple concept below. So if our estimating values are not the number can be observed, they are existing in possibility in the n dimension obtained by independent variables. And if we observe a lot of times under the law of large number, we will get a highest possibility of expected value in the end. But it will cost huge calculating resources. It may take a few years to get in the result. Hence, we use the Gibbs sampling and then do the iterations until the result coverage via the law of large numbers. And I described it in a more intuitive way. And Gibbs sampling fixed variables x1, 0, and operate the random forest model to predict the x1, 0. And the missing value in the x1 variables is predicted as the v1, and the x1 0 become x1 1, and then fix x2 0, and make another random forest model to predict the 2 0. And the run once process from the x1 to xn is an iteration. In this study, we did 10 to 200 iterations. So combine the random forest and the Gibbs sampling. I subconclude the model's framework. After wash the raw data, we build a simple linear regression models for estimated target variables which have a high correlation to independent variables. Then use the Gibbs samplings of each variables, and every independent variables take turns as dependent variables for iteration. And each dependent variables will be imputed missing values by random forest model assembled. They choose the row and the column as new small vectors for country models temporarily. Then, after iteration of gap sampling, every random forest model came out in subset, and then assembled those subsets as the output for the second layer in knife set approach. And to compare the simple algorithms with IPCC's Tier 1 method using broadleaf forest parameters, 5 indices were considered. They are mean absolute percentage error and root mean square error and the mean square error and the mean error. Okay, now we start the discussion. For carbon stock and the sinks are usually estimated by regression models, and the regression models work well for above ground carbon stocks and the sinks, but are relevant in effect for below ground part. And this mainly because the relationship between the independent variables and independent variables are commonly chaotic or divergent and appear everywhere in nature ecosystems. There is large variability in below ground CCS estimated among sites and high estimate uncertainties, which can be attributed to environmental and anthropogenic factors such as temperature, precipitation, soil chemical properties, and biotic communities, nutrient availabilities, management intensity, and ecosystem productivity, something like that. And bamboo forests are one of types of terrestrial ecosystem in different climate classification zones will have totally different amount of the carbon stock and sinks because they have the rhizome system and can transport the carbohydrate to other places and support the young or new root development. So they have a more higher chaotic characteristic in their study site, in their habit. And above ground carbon have a significant correlation with spatial area, and it's quite sweet for constructing linear regression to estimate the above ground biomass. And Okuda Sensei in 2006 also made this kind of linear model to estimate the moso bamboo's above ground biomass in Japan as well. And we also found the heterotrophic respiration have a significant correlation with the ANPP and a slight significant correlation with the litterfall mass. Perhaps it means that if microbiome communities in soil decomposed organic matter supply from litterfall increase and then nutrient resupply to moso bamboo, it will cause moso bamboo's MPP increase. Or total nutrient in soil drive the activity of microbiome to activate the N cycles, ammonifications and the nutrifications, and cause the heterotrophic respiration has been driven as well. However, just only 2 peer-reviewed studies recorded total nutrient in soil and heterotrophic respiration at the same study site in China. And the AMPP just have a slight significant correlation with the total nutrient in soil. And the observations number is only 3, 2 in this study and 1 in China. The relationship between the soil nutrient, heterotrophic respiration, and AMPP has potential for discovering the insight in the future. And the below ground net primarily production has a significant correlation with deep net production. Perhaps it implies that the more leaves form, the more root and the rhizome grows because most of bamboo's leaves produce sugars and the supply for developing roots and the rhizome. The table revealed the performance of knife set approach, and the approach is better than the IPCC's Tier 1 methods using broadleaf forest parameters in all of the indices. And from the sorry sorry, and because the IPCC Tier was above ground carbon, below ground carbon, and the total carbon stocks have a lower performance than the knife set approach. And in this kind of figure, the y-axis is the observations value, and the x-axis is the estimation value, and the MPP, BMPP, and the TMPP. Even though the result seems not so good for the knife set approach proved, but it's still better than the IPCC's Tier 1 methods. And I think perhaps we needed to collect more nutrient data from the other study site, because it's very lack of this kind of data nowadays in most of bamboo forests in the world. And after we did the 10 cross validations, we also operated the holdout data set to make the holdout testing. And the performance is very similar with the 10 cross validation, which means there is no overfitting of the knife set approach, and all of them performance is better than the IPCC's Tier 1 method. Okay, so through the collecting Mossel bamboo's data worldwide and operating Pearson's correlations, we found the above ground carbon stocks and the basal area have a high correlation to each other, and MPP and the leaf net production also have this kind of phenomenon, and the MPP and the heterotrophic respiration or total nutrient in soil have a correlation with each other as well in the phyllostash Edwards stand. And the performance of the knife set approach is better than bodily forest parameters using the IPCC guideline for estimating carbon stocks and sinks in phyllostash Edwards stands. And we believe the KS approach also can be applied in other forests if the dataset is reliable. Thanks for your attention.